Hello, everyone. Thank you for joining today's webinar. We're very happy to have you here with us. Um, we're celebrating the Refrigeration Day worldwide, and we're doing our own way. So having two very experienced guys of Embraco and Nidec that are gonna show and introduce very relevant topics today. We're gonna discuss about global long-term solution for commercial refrigeration. Let me introduce myself first. I'm Johari Gregorio. I'm an application engineer for Nidec Global Appliance, representing the Embraco brand. I've been working for Embraco for 10 years, both in Europe and here in the US. And I hold a bachelor degree in mechanical engineering. Let's now move to the topics we're going to discuss today. We're going to have a brief introduction. Then have an overview of the global context and discuss about natural refrigerants in particular. Then move to global trends and global long-term solutions, so like future-proof. And Andre is going to discuss about some case studies that are going to illustrate, improve the solutions. Then go through the digital tools and a Q&A session. For all of you that are joining today, please, I invite you to just write the country where you're writing from, because that's very interesting to know. And actually, I appreciate that several people already sent some questions before this webinar. So that's very interesting. Many of you already wrote to us, and we're going to go through that and hope that this webinar is going to answer most of the questions you made. And all the ones that are not going to get answered during this call and this webinar, we're going to make sure to reply to all of them afterwards. So let me introduce the two best guests we have today. I'm very honored to have both of them because we've been working together across the globe as well, also in Europe, but not only there. Myself and Marek are located here in Georgia, and Andre Rosa is in Brazil. Marek is our director, a research fellow. He's been working for us for more than 40 years. He's a pillar of our R&D department since ever, and developed products that were pioneer products for the refrigeration industry since ever. He's now member of several global standards bodies from IEC, UL, and Scanina in particular. That's something Marek is going to talk about later on, and ASHRAE. And I'm very honored to have him today. Thank you, Marek. And also Andre Rosa is our commercial appliance R&D and product strategy director. He has 20 years of experience with us in refrigeration compressors. He worked in mechanical labs, developing compressors, leading labs, and then leading different R&D teams worldwide, so in Europe in particular, and also in Asia. And he's now located in Brazil at the headquarters, and he holds a bachelor degree in electrical engineering and a master degree in scientific metrology. So thank both of you to join today's webinar. I'm very honored to have you, both of you. Let's move to on a broader perspective. What's the global context? On a broader view, there are global agreements and goals to mitigate the risks of climate change that we see basically every year. We see the impacts of those. So there was a Paris Agreement that set already some targets, and then even further the Kigali Amendment to the Montreal Protocols that set very strict, let's say, targets of HFCs phase down up to 80%, as we're going to see later on. So there is a broad understanding about climate change, and also there are initiatives to mitigate those effects. Refrigeration plays a key role on that, considering that about 10% of global CO2, carbon dioxide emissions, are related to refrigeration, and 20% of emissions come from refrigerant, so HFCs, the chemical mixtures, and 80% from energy use. So these two factors, so on one end, the refrigerants, the other one about the energy, are two main concerns. So how are those be addressed today? There is a refrigeration phase down, of high GWP refrigerants. So as we're going to discuss later on, the long-term solution would be low GWP refrigerants, and also regulations to improve the energy efficiency on a global perspective and also on a regional one, as we're going to see. The Kigali Amendment to the Montreal Protocol has set strict rules and targets in terms of HFC phase down. 121 countries signed this, and the European Union is basically leading this regulation in terms of phase down of the F-gas, and also the US is following with the AIM Act. And as there are two main groups, the Article 5 and the Article 5, that basically the non-developing countries and already well-developed countries with different targets and dates. So by 2037, the developing countries are going to achieve already the 80% reduction, and by 2047, also the non-developing countries. So this means that by close to 2050, all of them are going to be aligned to a target of reducing by 80% the HFC production and use. So it's a very ambitious plan. And also in terms of energy regulations, in this there is not a real global consensus, but there are like regional initiatives and regulations. So the eco-design in Europe with different revisions, and in the US there is DOE as a compulsory regulation, E-STAR as a voluntary one, AWEF, and EPA initiatives in general. Also in Asia, Japan has a top runner program, Australia has also other programs, and China doesn't have specific regulations, but as a major exporter has to comply as well with what the final markets are going to require. So on a global perspective, there are regional initiatives and regulations that strive to provide like high efficiency and low energy consumption solutions. In this scenario, we as a NIDEC Global Appliance is part of NIDEC, a division that serves commercial and household markets. We are accompanied with two headquarters, one in Brazil and the other one in Italy, with 16 manufacturing plants and more than 15,000 employees around the globe, and annual production of more than 70 millions in terms of compressors and motors, and present in 80 countries and plus more than that actually, and very focused in R&D. We do have 9 R&D centers with more than 500 engineers across the globe. So we are really engineering company, and we feel the responsibility of playing a role in this global scenario related to climate change and providing energy saving solutions. So we've been pioneer in this market. It's almost 50 years now, actually this year is 50 years that we are in the market providing solutions, energy efficient solution, because as said before, our focus is, we're a very engineering company, and we focus a lot in research and development. The research and development is driven to provide energy efficiency solution, reliable solutions, so meaning compressors, but not only compressors, as we're going to see later on, and high quality products that last long. And I'm quite sure, as you can see here at the bottom, almost 1 out of 5 compressors in the world are made of Embraco. So I'm quite sure that many of you has a compressor that we manufacture. And when you talk about the commercial refrigeration, light commercial refrigeration, it's almost 40% of the compressors in the market are Embraco. So we are closer to you than you might have think so far. And that's because of a very wide portfolio commercial for commercial refrigeration in terms of compressors and variable speed compressors. So not just the single speed or fixed speed compressors, but also variable speed, and more complete cooling solution going from condensed unit to sealed unit. And these are all made to serve different markets. So from the merchandisers to food service and food retail, but also medical applications that nowadays are very important, as you all understand. And those solutions, are pretty broad, up to 2 horsepower in terms of compressors. And the sealed unit are both with HFCs, but also mainly with R290. We've been pioneer in that. Now I'm gonna introduce Marek and let him talk us about the hydrocarbons and the new the latest news about regulation in F-gas and energy efficiency.
Thank you, Giovanni, for your nice introduction and let me say introduction to the topic. As you know, Embraco, as was said, is pioneering in natural refrigerant solutions since a long time. In fact, probably some of you already saw those slides, but just to remember that our journey with natural refrigerants started in early 90s, where the time where we were switching from R12 to R134A. At the same time, we started working on isobutane, basically on all hydrocarbons. And a part of Foron that launched was really the first refrigerator in Europe using hydrocarbon mixture. The first isobutane appliance was using Embraco compressor tabletop in 1993. Then we worked with Italian manufacturer to develop a portable air conditioner and also the humidifier using propane in 94. So it was also quite early in the time. The technology of 600A expanded to Asia in 96. Two big Chinese manufacturer, Higher Cologne, adopted German technology from Europe using 600A as a refrigerant for household applications. The same year, we had experience also with propylene used in commercial freezer in Germany. In 2008, so the natural refrigerants, mainly in household refrigeration, started quite early. But as you see, also commercial refrigeration started using hydrocarbons at the time. We have to say also that every time we're using hydrocarbons in place of traditional refrigerants, we got huge advantage in terms of efficiency. I will be talking a little bit more about this subject. In 2008, Embraco developed also CO2 compressor that had quite significant success, especially in Japan. But because of size, probably the CO2 technology in the light commercial small applications is not the best solution. In fact, we believe that hydrocarbons is the best one. In 2008, we started selling compressor to US. Our compressor was the first approved by UL to use with the propane on ice cream freezer in US. Then in the 2015, Embraco, working with American manufacturer of biomedical application, launched the first variable speed ultra low cabinet -86°C using cascade system with propane on the first stage and ethane on the second stage. And this technology now is spreading around the world. I believe that most of the units now working for vaccine distribution are using already natural refrigerants in their applications. In 2019, we reached the threshold of 50% of our production sold for natural refrigerant. So, and this percentage is growing year by year. Obviously, considering our market segment, we are not talking about all the refrigeration in absolute. We are talking on specifically on self-contained applications. Then here is the chart explaining the main two reasons why natural refrigerants, specifically propane, are the best options. First of all, propane is extremely efficient. Those results you can see is our study done for EHRI ARE program in 2016. The program started already in 2014. So we were able to compare different low GWP options to replace 404A. This was a main refrigerant in commercial refrigeration since then. And as you can see, we have substantial gain of efficiency using propane over obviously 404A, but also over the all the let me say alternatives of A12 safety class present today on the market. This benefit is even higher on the real application because of heat exchange properties and also other effects that those mixtures with high glide are creating. Second important element of, let me say, benefit of using propane versus those mixtures is the extremely low thermal level of compressor. The compressor final compressor temperature is much lower. That means obviously much lower thermal regime of compressor, so much longer life, less stress on materials used in the compressor. So in summary, the advantages of propane over let me say A12 mixtures are, as I said, first of all the efficiency. The second one is the lower discharge and internal temperatures. There is no temperature glide that is making easier to design the heat exchangers. The charge is extremely low. Normally, a rule of thumb is half of the charge of 404A is the charge of propane. Natural refrigerants are having lower price than the chemical mixtures. Obviously, the GWP is low. We are around 3 compared to 150 we have on those other alternatives. And for Europe, it's the benefit is that the pressures are lower, so it's easier with the existing, let me say, vessel volumes to meet lower categories in PED regulations. Obviously, the problem of all those new alternatives is flammability. Flammability in different level. So since I would say 2014 or even earlier, the industry through the various international committees are working to revise, to adapt the general and product standards to this new situation. So as you know, the so famous limit of 150 grams that was defined initially in early 90s for application in almost 30 years show extremely good safety record. So basically 150 grams is considered extremely safe quantity to use in the applications. So then let's go to review the status of the regulations, especially related to our segment of business. As you know, there are many committees in the world. I'm part of IEC. I'm really the chair of 61C committee, and we had quite significant activity on this topic in the last years. And now we are in the phase of implementing those changes in the different regions, because as you know, the global standard are standards, so they have to become, first of all, the regional standards, and then has to be enforced by local authorities to become a mandatory requirement. So in Europe, we have Genelec working on the European version. In US, the UL, and inside the Canina group with support of EHRI. In Japan, the JARAIA is working on the subject, and in Australia, we have the local national committees adopting the new standards for dealing with flammable refrigerants that will be the majority of refrigerant in the future to be in line with international regulations. As you know, the IEC standard increased the charge limit from 150 grams to 13 times LFL. That it means more or less with propane around 500 grams, but not more than 1.2 kilo. This was a limit that was adopted because of lack of, let me say, studies to show higher limits are safe as well. I think it's important to say that the task of the working group in IEC was to create additional requirements to the product that will keep the same safety level of 150 grams that was on the markets for more than 20 years. So these additional requirements are in those standards. And one very important point is the so-called Annex C that has to show that specific appliance will not create flammable concentration around the application. So this Annex C is an additional burden for those that will apply charges above 150 grams. Requirements for the system below 150 are not changing. So the standard is keeping the same let me say, elements that were in the standard before. The news is that the commercial ice makers are now part of the scope. Before was in DES 24. So household standard, now the commercial ice maker are the part of the scope. So in case they want, they can use a larger charge of hydrocarbons or A2L alternatives. Remote systems are excluded from this charge increase. So basically, this new standard is applicable for self-contained applications. So let's talk now about where we are in the global level in terms of implementation of this new IEC standard. As you know, most of the world countries are just using IEC like it is, so they are already valid in several countries. Australia and New Zealand published this new standard last year, 1 year ago. Europe and America are almost there, so they were expecting in this autumn to have the publication of European version of DES 89, and in US the UL version of 89. In US, the Canina group that worked hard during this year, last year, has a little bit broader scope than the original IEC standard, because we'll consider also remote systems, since in US there is no 378 like we have in Europe. So the UL version of the standard will also have a remote system, but only with A2Ls, not with A3s. So not propane, but A2L alternatives. In Japan, it's expected in October in the conference, the JARAIA will present the outcome of their studies. So in reality, we are waiting for Japanese edition of updated standard. So here is a chart showing more or less type of application that are covered by this DES 89. Ice makers are the new application inside the scope, but there are several other applications that are not covered by the standard. For example, ice cream makers, there's a new standard 118 that is not considering yet flammable refrigerants. So the work is in my committee now to update this -89 also for flammable refrigerants. Lab equipment today is using 150 grams limit, and they are also looking on different charge limits as well. In vending machines, so all dispensing equipment, water fountains, covered by the 75. Today, I don't know any action to change the charge limits. For all the remote system, walk-in cold rooms, whatever, this standard does not apply. So the ISO standard or EN 3780 in Europe or other standard has to be used in case people want to use the flammable refrigerants in these situations. So what this new limit, the question is where we can go in terms of cooling capacity. And here the dots on the graph with alt limit are the already existing equipments. The dots above the alt limit are, let me say, an extrapolation, or let me say, hypothesis. In this case, for example, this system has two separate circuits, so the total of the charge is 300. In this case, is just a projected cooling capacity you can use with single circuit having 500 grams as a limit, and this is a chart for low temperature. The similar chart for medium temperature, you can see we can get almost to 3,000 watts cooling capacity. In this case, the upper point is the system having today 4 separate circuits, so the total of the charge is almost 500 grams. Obviously, today, not having the 500 grams yet in US, nor in Europe, the manufacturers are using, for larger application, the multi-circuit approach. And this multi-circuit approach has several advantages. Like, for example, small tube diameter. They have redundancy. They have a possibility of having a multi-step regulation, and has no restriction in room area, and has not to, let me say, go through the leakage test of the Annex CC. So the multi-circuit option is also quite valid in several situations. Single circuit of 500 is where there are space limitations, so the overall dimension of the condensing unit is smaller because it has only one compressor. So and obviously has less complexity in terms of assembly and construction. This self-contained systems, multi or micro-distributed, or with single compressor with a large compressor, can be an interesting option to replace also remote systems, especially in medium-sized stores. I will not go deeper on the subject. You see here a link to the YouTube presentation that Umbraco prepared, and you can check it out after this webinar. Thank you. This is my part. I'm handing over to Johari. Thank you.
This was a great presentation. Also, the latest news you shared about the publication of the extension of the refrigerant charge also here in the US and in Europe, expected by the end of this year. That's a great news, actually. Thank you, Marek. I really appreciate that. Now I welcome Andre to talk to us about like commercial applications and the latest trend in terms of product supporting natural refrigerants and high energy efficiency.
Thank you, Johari. So let me go to the next slide. Second. So as we were talking, we believe you can see a nice picture of our variable speed, the VCC compressor, and the seal of the natural refrigerants. So we believe they are the best option, right, to minimize the direct and indirect impact to global warming. Okay, and I'll bring some more figures about that. In this picture, we can see the VCC compressors, the VCC solutions, and natural refrigerants. They're present everywhere, since the household application, the refrigerator, to the medical application, a hospital, to the display cabinet in the butcher store, to the supermarket with the reaching cabinets, in the restaurant where you go, to the delicatessen store, to the convenience store. So it's a wide range of applications. And on the right side, we can see some of the main benefits that the VCC technology is bringing. So we see the low noise and vibration that most of the times the compressors operate in a low speed. The temperature control, so the goods are exposed to a lower temperature variation. The variable speed and capacity, so the application is adapting to the thermal load required. Fast cooling and freshness, so you have the food fresh for a longer time. Wide voltage range, so due to the electronics, the application is able to run and to be more robust to the voltage variations in the network. Reduced pull down time, so the goods are in the proper temperature faster once you have a kind of reload of the goods. And for sure, last but not least, the very high efficiency of the application that you can get when you have the VCC. And then I would like to introduce a little bit about how this energy savings and temperature performance gets better, right? So we see here, starting from point 1 on this graph, we see that you can see here cooling capacity by efficiency. And you see this green curve is the performance of a VCC compressor. And the orange dots, they are representing several on-off compressors, single-speed compressors. So we can see that one compressor in VCC compressor can adapt to the thermal load, right? And can even replace several models of single-speed compressor. And by the way it operates, right, by the control, you are able to apply to a VCC compressor. We see an effect on point 2 here, that adjusting the speed to the thermal load, we can see that the temperature variation inside the cabinet is much lower compared to the single speed on-off compressor, right? This is a strong benefit for the goods. And then a third point is that the VCC technology allows to be operating in a condition that is more favorable to the energy saving, right? We illustrate here an example where we see that a representative on-off single-speed compressor going to a VCC, right? We can increase the evaporating temperature, right, and decrease the condensation temperature. So by working in a lower delta temperature than delta pressure, right, it also provides a better energy performance of the system. So we have the two main reasons, right, why we get this great saving in energy. So the compressor itself is quite efficient, the VCC compressor, it's COP as we say, or ER, and also it allows the cabinet to be operating in a more favorable condition for the energy savings. But it's not only energy saving, right? So we see here in this graph representing in the light green, the single speed on-off compressor turning on and off, right? Switching between the nominal speed, in this case here, 60 Hertz, right? 3600 RPM, and compared to the variable speed, to VCC compressor, where we can see that in the low demand, it's operating in a very low speed, close to, so in the minimum speed. Then with high demand, it switches the speed, so according to intermediary speed, according to the thermal load. And then when you have the event like a pull down or a reload of the goods, right? Then it goes even above the maximum speed, the speed of the single speed compressor, right? And then can recover the temperature faster and can come back to the low speed. By doing this, most of times the compressor is up to 5 dBA quieter compared to on-off, right? This is a great noise improvement, bring comfort to the end user, right? And bringing noise and vibration improvements to the cabinet. Then talking a little bit about what we see as global trends and challenges, right, in the segment. We see that there is overall in the refrigeration, the commercial refrigeration, there is this environmental push, right, that is coming some part of it from the regulations and the other part by the awareness of the end user on the energy savings and the other benefits. Okay, migrating to both natural refrigerants and also to the variable speed technology. And we show here, we highlight here some of the challenges when we look to each segment. So food retail, food service and merchandiser. In food service, we see that the challenge is efficiency increase in the cooling system and in the doors, right? So several applications, they have large glass doors. And the GWP reduction with natural refrigerants, right? This is a challenge that is coming. Some markets are more mature on that. Some markets still have room to make this evolution. In food service, we see that there is an increase in sanitation standards, okay, and also new practices in food preservation, and these are related also to the cooling circuit, like temperatures control and logging of it. And in merchandiser, we see a strong consolidation of low GWP use like R290 propane, okay, and we see also as a relevant challenge the next generation of efficiency increase, right? That we see it already arriving, even the variable speed being adopted in the merchandiser segment. And we as Embraco Nidec, we are serving the market with reliable, robust, and efficient compressors, right? Supporting this target, supporting this trend of GWP reduction and energy regulations and energy efficiency push. Then when we talk about the VCC, the variable speed, a very important component that we have, right, the difference we have is the inverter. And I'm highlighting here some of the features, right, that this technology provide a better experience to the application and to the user, right? So first one highlighted here is dual voltage. So we have already for some years in the market these inverters with the dual voltage, so we can operate in 115 nominal or 220, also 50-60 as it is electronics. We have our inverters with all-in-one communication, so it means if you have serial frequency or even the regular thermostat, mechanical thermostat, right? We are able to adapt with the same inverter. We have the on point 3, the smart drop-in logics that is able to optimize the performance, right? And it's very easy to use when combined with the software tool, the U control that we are picturing here in the center of the page. Our inverters, they have the LED diagnosis to improve the servicing in the field. Robust design to work under, let's say, challenging ambient conditions. And of course, they're all approved to work with flammable refrigerants by all agencies, right? Not only the famous VDE and UL, but all other agencies around the globe. With that said and introduced, I would like to bring a few case studies with some figures, some numbers about the results that we can get applying both the variable speed and natural refrigerants. I'll bring here a couple of cases, one applying this model that we call FMFD, and the other newest model launched that we call the VMP. As for the first one, we bring here a frozen island, right? This is an equipment largely used in the food retail segment, where in the baseline we had this model, single speed on-off compressor, that was applying the R404A refrigerant, okay, with, you can see here the energy consumption, so around 11 kilowatt hour per day. And then migrating to the FMFD 413U, that is our VCC, with R290, so the combination of VCC and natural refrigerant, we were able in this case to reduce 30% in energy. That for this particular case gave to the end user a payoff in the initial year, so within the first 12 months. This is a great result, and then the end user can enjoy all the benefits, but enjoy the saving for the rest of the equipment life. This is a great benefit and shows that not only by regulation, but also by the interest of the end user, this combination is being well accepted and demanded by the market. And then the second case, it is a merchandiser, is a bottle cooler. Okay, the volume is 562 liters, where the baseline was already a compressor with R290 refrigerant. Okay, this compressor is already a high efficiency compressor, is 1.7 watt per watt in natural LBP. Okay, where we can see here some pictures about pull down time, the half reload recovery, and the energy consumption. And by switching to the VMT 404U, we can see that the combination of natural refrigerant and VCC here brings 22% saving in the pull down time, 16% in the half reload recovery. It means that the goods, right, the beverage inside, they will be, let's say, in the ideal temperature for the end user in a faster time, right, in a shorter period. And this brings also the combination of much better energy consumption. So in this case, from a baseline of a high efficiency on-off compressor, we still bring 35% energy saving. That is a great result, right? So we have the goods that are in the ideal temperature in a shorter time, and the energy consumption is lower compared to the baseline. Then, just to illustrate you briefly the lineup we have for the R290 VCC compressors, we show here some of the main families that we have, and since the small compressors to the largest that we have, right? So we have here the VMT, the VM series. Then we have the FMF family. We see here 2 levels of energy efficiency. The FMFT that is already in the market for almost 5 years, and then we have the FMFD that we launched last year, and the VNE, okay, that we have for almost 10 years in the market, and we are launching new models in the recent years. And all these models, they are available to a wide range of applications. We illustrate some of them here below. Okay, you can see some merchandiser, food retail, food service equipment, and also medical equipment. And there are several other segments and applications that can enjoy this lineup of compressors. And last but not least, to close, just to briefly highlight to you all our digital tools. So we have our website, embraco.com, that is available in 11 languages. We have, you can find easily there our technical blog that we call Refrigerations Club, that is managed by Embraco for over 30 years. You can find online also our product selector software that we call the PSS, and the tool where to buy to find the nearest distributor. And you can also have the Embraco Toolbox application in your mobile. So it's available in 10 languages, both for Android and iOS. And of course, our social medias that you can see: Facebook, LinkedIn, and YouTube, where we can also find Embraco Nidec. So thank you very much for your attention. I switch back to Johari, please.
Very much, Andre. This presentation was very interesting and detailed in illustrating the benefits of variable speed, not just for energy efficiency, that's a major thing, but also in food preservation and noise and reliability long term. And also, it's very broad applications. That's very interesting as well. So, everybody, thank you for joining so far our webinar. Now we are open to a Q&A session where we're gonna hear your questions and reply to them. Thanks to all of you, because we already got some questions before the webinar started, so we're gonna go through them first, and in the meantime, if you have any questions, we're gonna answer them live. So one of them was for, I will ask here Andre to support, is a question about how do you see the future of variable speed compressors application for energy efficiency?
Well, Johari, I see that there is a trend of market asking for a wider range of compressors, as I showed before. So since the small ones to the largest ones, and we see the trend to keep improving the energy efficiency of these compressors, right? We see that the market is still valuing a lot the high COP, high EER compressors, and we should keep going in this direction. This is the way I see, right? As Marek showed, that there is a matter of legislation, but both on energy and on the refrigerants GWP. But as I showed in the case studies, there is also a push from the customers, from the end user, from the market, let's say, okay, choosing the high efficiency compressor and the combination of variable speed and the natural refrigerants.
All right, thanks. So basically, there is on one end regulation pushing for that, but also you see a market trend towards a more energy efficient solution. That's a very good comment. Thank you. Moving on now to the second question that we got before the webinar is about the components used in the compressors for R290 for in how they are approved to handle flammable refrigerant leakages. So like there is a question from Sirio from Italy. And here, a main thing here is about how you build, I will answer this question, is how you select the components. So all the components of the compressor, but also the whole application, the electrical components should be compliant to the IEC 679-15. So this means they should be sealed or semi-sealed. This means that they're not like as a ATEX rating, but that in case of there is a spark, the flame is contained and does not propagate far off. So if you have all our compressors are already use components that are compliant to the IEC, and we suggest also for the whole application you do the same. Mark, you want to say something?
One comment, yeah, just to slight correction. On compressor, obviously, has to be compliant with 17915. On appliance, the manufacturer has a choice, or to use the, let me say, 17915 components, or ATEX components obviously are working as well, or to demonstrate by test that the leak, in case of leak, will not reach the sparking device. So this is the present standard requirement.
Yeah, so the dual approach. Either you want to be peace of mind, you select components already approved to the IEC, or you perform the leakage test and check the concentration around surrounding your application. All right, thank you, Marek.
For the present standards like this, so also below 100.
Sure. Thank you for that. Now here there's a question I will ask Andre to support in that. There is Rohit Sutar from India is asking which natural refrigerant is suitable for big commercial refrigeration?
Well, let's see. That then depend on what we call big refrigeration. But let me go briefly through the overall range, right? So if we start from the range we are showing here, for sure, we see that propane is the best solution, but not only. In a very small application could be R600A. Then a growing range, we see as natural refrigerant coming the CO2, okay? Let's say from power like 5 kilowatt up to, then the limit is not precise, right? Could be 20 kilowatt, 50 or even higher. And then when we go to really big commercial application or industrial application, then it would be ammonia, right? In a very large application. So this would be the range of natural refrigerants, considering the overall range of commercial applications.
Thank you, Andre, for the answer. I appreciate that. Let's move now to another question that is about the VCC from Mukesh Lutman. Sorry, I hope I pronounced it correctly. Is asking about the VCC compressor, if it works with variable voltage and not hertz, not variable frequency. I'd answer this question. So the VCC compressors, variable capacity compressors, they're basically compressors with a brushless direct current compressed motor, three-phase, coupled with an inverter. The inverter has the function to convert the single-phase power from the power outlet to a three-phase signal to the compressor. So the power outlet is still the same. It's going to be either 50 or 60 hertz. And the main capabilities about the inverter is that we have inverters that support both 115 and 220, the same inverter, and regardless of the frequency, it can be either 50 or 60. So it's not variable frequency, the input power, that's going to be the standard 50 or 60. Well, what changes is the inverter is changing the frequency of the motor, but not the power outlet. That is going to be the same. All right, moving on to another one, and this is about from as a comment we just got live, is what are the most important 70 procedures when handling flammable refrigerants? And I'll support on that and answer to this question. One thing is about when you are designing an application. So, and another thing is about doing maintenance. Looking at the design, as we said before, you want to look at the components, all the electrical components, to make sure, at least if you want to be, want to have peace of mind to select all of them, either to be brushless, fan motors, motors in general, or be compliant with the IEC 600 79-15. Or if you don't find available in the market components that are compliant to the standard, you will have to carry out the test according the leakage test, as already Mark mentioned before. When you go in the field, you have to handle that. You want to make, first of all, a risk assessment when you find an application in the field that you have to service, to understand if there are any sources of flame. You want to have components that are approved to work with hydrocarbons. This means like a recovery machine and any other electrical components you have should be specific for the hydrocarbons, for R290. Also sniffers and so on. So you gotta have specific equipment that are made for handling R290 or even R600A. So that's the procedure I will suggest you. And in general, we support several organizations that organize training, detailed training, because this is not a pretty wide of a question, and training is key and important to know how to handle the natural refrigerants properly, because there is really a lot to know in terms of details that you have to look at. But in general, that we see also a trend in terms of teaching and having people qualified that are moving in that direction, and we support actively this type of training and dissemination of information. I see. I don't know, guys, if you have any other comments that you would like to add, because I don't see any other questions.
I think that we are here to answer also other questions that you didn't mention. So after this webinar, we will try to address those points with who is asking for. So thank you very much for asking. No, and we are here to support you in answering, and obviously use our digital tools where you can find the various elements, including the position paper on refrigerants that I think is quite interesting to check out. Thank you.
Yeah, thank you, Marek. You said very well. So this webinar is going to be still like in YouTube, but you can find it also later on. Subscribe to our Refrigeration Club, where you can find a lot of information related to refrigerant and trends, and also to our social media to follow ups there. And all the questions that you made us either were answered during this presentation, and the ones that we had no chance to answer, we're going to answer later on by email. So be sure that we're going to follow up on that. So thank you again, Andre and Marek, and see you soon with a new webinar anytime soon to discuss these relevant topics.
Thank you, guys, and thanks to our audience. Okay, see you soon.
Thank you all.
Bye-bye.
Thank you.